Hello, everyone. Welcome to the first episode of NativeScript Air. I've got with me a couple of guests, and today we'll be talking about performance in NativeScript. So first, I have Stanimira Vlaeva from BG. Stanimira, can you introduce yourself?
Yeah, hi all. I'm currently working in the NativeScript team and basically focused on NativeScript Angular, optimizations, the Webpack story, and so on. So that's about me.
Great to have you here, Stanimira. And we also have Nathan Walker. Hey, Nathan, you want to say a couple of words?
Hey, everybody. My name is Nathan. I love NativeScript and love working with it. And I try to take everything Stanimira does and break it. And I'm looking forward to talking about performance.
Excellent, excellent. So, like, just very quickly, like, how did you guys get into NativeScript? Like, what's your story behind it? Nathan, do you want to tell us about it?
I'll do this quickly. I was working on a project, and we were at the time doing hybrid development, and my boss was not quite happy with it. So we were trying to figure out how we could get into pure native development, and we had done a little prototype in pure Objective-C, and he liked that. And so NativeScript kind of came on the radar around the same time. React Native, of course, was also on the radar, but we had built our app in Angular. So I specifically was looking for something that worked with Angular, and luckily NativeScript had a pretty nice integration at the time. There were still some rough edges, but it worked with Angular. And so we decided to kind of give that a go, and that was kind of the start of it. So I tried to develop a couple prototype apps for fun, yes, but also for serious evaluation too, so trying to figure out if it actually would solve what we were after. And the other side of that is code sharing has always been kind of a desire of mine over the years, and so I immediately, early on, had seen some opportunities that could create some really nice code sharing.
Excellent, excellent. How about you, Stanimira? What's your story?
Well, what's my story? I don't know, I just got this job offer for working at NativeScript, and it's basically the coolest thing you can do in Bulgaria, so I started into that.
Excellent. The coolest thing in Bulgaria, NativeScript. I like that. I like that. Okay, cool. So let's get on the topic, because you got like 1 hour. So basically what I did, I built this very small application called NativeScript Football. And by the way, for you, Nathan, and anyone on the other side of the pond, football is the game where you actually kick the ball, not the one where you carry it around. Yeah, the game you call wrongly soccer. It's really football. So anyway, like, I built this small application and I sent it over to Stanimira to have a look. And basically what we probably do is just goes quickly, step by step, in terms of like how we could improve this application. So I'm gonna share my screen, because I will be doing the things hands-on, and Stanimira will be telling me what to do. Can you see my screen now? It should, as well as like say save the date, etc.
We cannot see the screen just yet.
Maybe I have to choose the right screen. All right. Oh, because I was doing presenting. Oh, let's see now. You should be able to see it.
Yep, we see it.
Excellent. So, so basically, while I'm here, it's worth mentioning that we're gonna have like a NativeScript Developer Day in New York on the 18th and 19th of September. I think you both are gonna be there, but for anyone that's watching us, it's a great opportunity to come and say hi and meet us in person, and as well as see some of the cool things we're gonna work on. So the project I mentioned, it's on GitHub. You can find it under github.com/sebavita, and it's basically called NativeScript Football. So like I'm gonna open Visual Studio Code, and I've got my application here. So what do you think, Stanimira? What can we do with this so far?
Well, first you can tell us about what's the problem with your app. I think it's the startup time, as you mentioned before. What's the startup time of your application right now?
So I think like when I run it, it takes like about 5-6 seconds to kind of load it. like
for Android, right?
Yeah, and I think that as well measures how long it takes to, for example, load the data that I have on the screen. So basically what the app is doing is just showing the tables from the top 4 leagues in Europe. And then, for example, if I choose like a Premier League and I go to view fixtures, it kind of like shows me what sort of games have been played. Or if I click on like one of the teams, I could see like what are the players, etc. So the app could, yeah, definitely do something with improving the performance and how long it takes to start, because it's not perfect. So, for example, if I just kill it and then start it again, it kind of hangs out there for a little while before it actually shows up.
All right, so it takes some time to load, and we can just make it faster, right?
Yep.
Can I take a look at your app module, right? The root module of your application.
Sure. So
that's a NativeScript Angular app, right?
Yes, that is, yeah.
Okay, then. So that's your root module. That's all the components and pipes that you're loading at startup time. I see quite a few of them. Have you thought about separating these components in different engine modules?
Yeah, so in a way, like I structured my application so that I have, like, for example, all the components for, let's say, showing the team. So being the team component and the player component into like a one module. And I as well have like my fixtures separated, like the fixture component in separate module as well. But yeah, like at the moment, like I'm loading all of them in app module. So what do you suggest we should do?
So you separated them on engine modules. And what is actually the component that you're showing at the start screen? The table that we see, that's probably tables component, right?
Yeah, so basically tables component is basically the view. So like this is my tables component, and each of those tabs basically displays a league table. So I definitely need those at the very beginning when I load my application to begin with.
Okay, but then you don't need the other components. And the cool thing is that you already separated them at engine modules, which is basically the right way to do it when you have Angular applications. Just put everything in different feature modules. So there's a cool feature that comes from the Angular router, and it's called lazy welding. Of course, it's not just invented by Angular. It's very well known, but with that feature, you can just have the different engine modules that are not required at startup to be loaded at some later point of your lifetime, of your application. For example, when you navigate to the feature or the teams, so then you're gonna load that chunks, the different modules that are can be just fetched at later time in your app. Understand me, right?
Okay, so I guess we could probably try to do that. What do you think we should use to kind of measure objectively how long it takes to load the app? Because just eyeballing it, I don't think is gonna cut the chase, right?
Well, since your application for Android, you can use the there's a tool called Android Debug Bridge. It's ADB as a command line. And you can print everything that's happening on the device by using ADB logcat.
All right, so I just write ADB logcat, and then what? Like...
So of course that's gonna print a lot of things, so you can just look for the startup time. And one easy way to do it is, of course, to filter the output for the words displayed. Yeah, that's a bit of a hack. It's worked like that.
Okay, so if I run that, so it basically says like last time I ran the application took almost 5 seconds to start.
Yeah, that's the time it takes for that activity to be displayed, and that's your application. Org NativeScript and NativeScript Football, as you can see it. So yeah, it takes 5 times, 5 seconds for the second run.
I see. I see. So yeah, 5 seconds is definitely a little bit too long. All right, so let's turn my module into lazy loaded. So at the moment, like I'm loading all of them like using eager loading.
Yeah.
So I guess I could just replace this with load children, right? So
Yep.
load children, and so for fixtures, I have to go to where is that? So / competition. Actually, I'm gonna be lazy.
Well, while you're doing that, Sebastian, Stanimira, on Android and iOS, have you found that the lazy loading and startup times differ greatly between both platforms? Is Android more problematic in startup time than iOS, and is there any indication as to why?
Well, yeah, we're gonna see that later when we run some profiling, and I'm just gonna go through everything that's happening on startup and explain why some of these things don't happen on iOS. It's basically because we're using different JavaScript engines for our Android and iOS runtime, but of course there are other reasons for that.
Excellent.
Yeah, while Sebastian is doing the lazy loading, I can share. We have an article explaining how to do lazy loading in NativeScript.
For the viewers and listeners out there, the one thing that has really piqued my interest and has continued throughout dealing with NativeScript is the core team's attention to performance. There really seems to be a constant focus, and with every release, there's some little performance tuning, and so that's been something that's really been exciting throughout the time I've been working with it.
Nice.
Thanks.
Yeah, I think like that's definitely something I've seen over the years of like how NativeScript has been progressing. Like it's just automatically just every few months you see massive improvements in all sort of areas. So yeah, performance was a big boost in the recent time.
Speaking of one, and I just want to mention one last thing, there was a recent merge into master, I think, that dealt with iOS performance and garbage collection. Do you know about that one, Stanimira?
Well, yeah, we had some. You're talking about from the past few days, or?
Yeah, I think it was just last week, maybe Thursday or Friday even.
Yeah, we had some memory leaks that we identified, and we made a few changes to just remove them and make the iOS faster.
That looked like some pretty big performance gains, definitely.
Yeah, that's nice.
Cool. Okay, so just to complete it, so I'm now lazy loading on my modules, so I guess I can just get rid of them from here. I don't have to.
You have to do that actually, because you should declare your components only in a single Angular module. That's required by the ahead of time compiler of Angular that we're gonna use later.
Okay, I see. So I'm just gonna do the usual TNS run Android, and FYI, like what we see in here is my old Samsung S6. So I'm not running this in an emulator. I'm running in a real device. So the results we're getting are the real results for running the application.
Notes for users who are testing their applications and startup time. On emulators, they're always faster. So it's better to test them and develop them. Well, maybe not develop if that's not convenient, but to test them on real devices, because then you're gonna get actual results.
Yeah, totally. So let me see now. So now the startup time is actually 3.8 seconds. So lazy loading has already had some good effect on my application.
Just to summarize what happened, we are only loading now the tables components and the leaks components, right? And all of the other things are separated. We're gonna load them, more like Angular is gonna load them when we navigate to that pages.
I see.
For example, if you navigate to theme module, I think it was called, then it's going to take some time to load that module.
I mean, it still was pretty fast, like it was almost unnoticeable, but if it has effect on initial load, yeah, that's when you notice the most.
Yeah, and of course for that app which has only 3 modules, the difference is not a huge one. But if you imagine a real-time app that have 10 plus or even 20 ng modules, the difference can be really significant. Like you don't need these things a startup. You just want to show the startup screen and then load them.
Definitely. Okay, so we already had some improvements. Like, what else can we do?
Well, what we can do now. Okay, I may have no ideas, let's say that, but let's run some profiling for our app and see what it takes time. You know, this 3.8 seconds, so probably that time goes somewhere. And we can use this awesome tool that we developed during the last release. That's called Timeline View.
Okay.
Yep, you have to install it globally with npm. Of course, it's not necessary to be globally, but you basically can use it for all your NativeScript apps, so it's better to have it that way. So npm install.
Okay, so let me see. npm install, you said globally. What's the name of the tool again?
Timeline-view.
Timeline-view. All right. Let me just
while you're setting that up, and before we totally move off the topic of lazy loading, one thing that might be nice to reiterate is that for a lot of web developers, especially those working with Angular, when they start dealing with lazy loading, the concept is somewhat different in terms of the gains that you might expect on native. So some people might not think they need to lazy load on native mobile because, of course, all the code's local. And I've seen that a lot, and so you'll have a common expectation or a common assumption that you don't need to lazy load in the native mobile app. And in fact, it's probably one of the biggest out-of-the-box things you can do to boost initial performance, because the slow load time is going to immediately give off that impression of a slow app. And so lazy loading off the bat is almost something you should do by default with any NativeScript Angular app for sure.
Actually, I have to admit that I was one of the people guilty of that, where I thought like, well, you don't have any bandwidth delay. Why do you need lazy loading, right? All the files are here. But yeah, I could see already the results changing. So definitely, yeah, we should follow your advice.
The thing is that, you know, the files are local, but you still need to read them from the file system. Then you have to execute them, and that takes some time, you know. You don't have the computational power of a personal computer. You have your phone, which is pretty powerful, obviously, but it still takes some time. And you have a lot of files, a lot of components, and it's like 20 ng modules. It will read 20 plus files from your device, and that's gonna slow up your startup time. So it's basically something that's pretty easy to do, to have lazy loading, and you just gotta take use of it, you know.
Sure. And it's actually quite an easy thing to do. Like, and as well, like if you design your application well and structure it nicely into like modules and stuff, like your application automatically is easier to read because you know what belongs where. So it's like a win-win.
Yep, sure. So back on the timeline view, how can you do it for your app? You have to add a single line to your package.json, but not the package.json that's on your root level, and the one that's inside app, the app folder.
All right, this one.
Yeah, so that's app/package.json. So
what do I do?
A new key that's called profiling, and its value is going to be timeline, just timeline without the view.
Yeah. No view? That's confusing.
And that's it, yeah.
All right, cool. So I've got that. So what do I do now to see the results?
So you just have to run your app again and pipe the output to that tool, timeline view. So TNS run Android, pipe, timeline view with dash.
Timeline view.
So you're piping it into this timeline view.
Yeah, the timeline view is taking the output and then generating a single HTML file that you can later on just take a look at.
And just to review real quick, you installed a global NPM tool and you just added one line to the package JSON, right?
Yeah, that's it. And then pipe the output.
Okay.
Cool. So let's see what happens. I run the build.
So yeah, when you enabled that profiling option inside your app package.json, the app starts being pretty verbose, as you can see. There are a lot of things printed on the console.
Wow, there is a lot of stuff in here. Like, how do I even look at this? It's like,
well, now you just have to quit the process with Control-C or whatever you're using. And yeah, the tool is pretty cool and prints where you can see the report. It's that times.html file that's located in the root of your project.
oh yeah, it's here.
Yeah, you can open it in any browser you like.
Okay, so revealing Finder. Let's open that.
So here we see a lot of things, obviously. And we see for all the top of the screen, the startup time. And of course, it's a bit affected by all these console logs because they also take some time to be printed. But yeah, we can see what's happening here. And in the beginning, it may be a bit frustrating what is happening. But can you zoom out a little bit?
Sure.
Okay. Just because I know what's happening in your app, you can see on the right, like, yeah.
Like all those things,
yeah.
What are these?
You can just hover on one of them. And yeah, that's some method called Listview Adapter.getView. So just because I know what's happening, it's rendering a new item in your list view. And these are the different themes in your startup screen. So you're getting them through HTTP, right?
Mm-hmm. Oh, right. So it's basically this renders each item from my list views from my actual application.
And they get into the startup time because, you know, the app starts, it's fully interactable, but you're still waiting to get something from a remote.
That's fair. I guess there's nothing we can do about that because that's basically, we have to render each of the items and we have to wait for the HTTP request to return.
And just for now, we can maybe remove that one just to see a clear view of the times HTML.
Okay, so let me do that. I think where I load the data in for each league table. So I have this load themes table. So if we isolate that, we'll see just the pure time it takes to load the application without.
We can just run it again
without loading the data. That's fair. Yeah. So then we can see the real impact of each of the changes we'll be making.
Actually, that's why your startup time got from 3.8, I think it was, to 4.3, because the displayed, the 8-big walkcat just shows how much time it takes for the first screen to be displayed. And then with this tool, you'll got some more time for rendering the different items, which happens after the startup.
Okay, cool. So now we are down to 3.6 seconds. That's a nice performance improvement. Just stop the data load, make the app unusable. Excellent. All right, so I can probably go reload this.
Yep.
Okay, so we got rid of the noise on the right.
So yeah, I'm just gonna go through some parts of this, and just to mention, there's a nice blog post that also explains what each of these blocks mean and how we can improve it, and what we can do as a NativeScript team to improve it later on. And I'm gonna send it later in the comments. So let's start from the beginning. The yellow blocks are what happens in our Android runtime. So basically, that's the Java code that's executing, and the blue blocks are the JavaScript code. Basically, our TNS core modules, any node packages that are executed, and of course your app code. So what happens on create runtime run? That's just extracting a few assets like XML pages, CSS, the init of the Android runtime, and things like that. Also, if you zoom a little bit on that block.
Just click on it?
No, just zoom.
Oh, sorry.
Yeah, with the scroll.
One moment, Stanimira and Sebastian. Make sure, Sebastian, your screen is focused in. I think it is on the recording, but just to make sure.
Okay. So it is now, right?
It looks like it is. Go ahead, yeah. Stanimira, sorry.
So here we see required callback. Do you see it? It's like the fourth block.
This one, yep.
Yeah, the required file is main.js. Just to summarize, you can actually open that in VS Code to see what's main.js.
Okay.
Of course, in VS Code is main.ts because in the device it's already transpiled to JavaScript. So yeah, that's the file, the starter file for your application. That's where we're bootstrapping our app module.
Okay, so basically it takes a second to bootstrap the app, right? Like.
Yep, and this require contains all of the other requires. Like inside we require the NativeScript Angular / platform, as you can see, that takes 700 milliseconds. And this one requires TNS core modules because they're inside NativeScript Angular. And of course, the second required callback is app module. Yep, this one. That's basically your application code. So it takes 300 milliseconds to fetch, parse, and execute your application code.
All right, so that's where we're pretty much loading my leaks table and the tables components, right?
Yep, that's right. So if you zoom out a little bit, we can move on to the next part of that. Yeah. So on create and load CSS on startup. Initially, you might think that loading CSS takes almost a second to load, but that's not actually the case. You can see the yellow box that's just below it. That's mark reachable objects. I won't go into much details, but that's actually part of our garbage collection process. And we're currently working on optimizing that part of the application lifetime. Now that's the synchronization process of the JavaScript and Java garbage collectors. And it takes a lot of time to work.
So wait, so that's when we're talking about the garbage collector from Java, like from native Android components, right?
Yeah, yeah, kind of. It's yellow, so it's happening in Java code. Yeah, that's the easiest way to tell which ones were.
Okay, so Android is slowing me down. I see.
Yep. Okay, so on to the next one. That's something we're currently working on, and we will try to disable that slowdown. But
okay.
what we can do right now. So as you can see, we are taking some time to require all these modules. On the left, there are a lot of required callbacks, as you can see. Yep. This
all
one.
of those here, yeah.
So these are all files in your device that we're trying to read and parse, and every trying to fetch a file from the file system takes some time. So one pretty simple thing to do is to just bundle these files into 2 or even fewer chunks. And one popular way to do that right now is to use Webpack or some other bundler, but let's go with Webpack.
Okay, I'm just gonna rename this file for now, so that we know that's like our step 1, right? And then, all right. So so you just said the magic word Webpack, which is dreaded by a lot of people. So I'm glad you're here, so you can take me through it. What do I do?
So how Webpack works, you have a Webpack configuration, and you can set up a lot of things. Your Webpack configuration, of course, is pretty specific to your app, but we've done something that can make that process easier. And we created the NativeScript Dev Webpack plugin that provides you with default Webpack configuration and some ways to start your app. I just install it and we'll go through everything it does. You can install it from npm.
Okay, so what do I do? You said npm install.
Yeah, it's dev dependency, so yeah.
So save dev.
And NativeScript Dev Webpack.
NativeScript Dev Webpack. Is that how it is?
Yeah, that's it.
All right. Do we have anything like somewhere I can read about it? Like if, you know.
Yeah, we got a pretty big documentation article. I'm gonna say it later, but yeah, it's pretty
cool. Yeah, we definitely add all the links in the YouTube comment section.
Sure.
So, yeah,
so
that'll be good.
See what it does. It prints everything it does on the console. It creates some files that's on the top of the screen. There is the Webpack configuration, tsconfig, which is a TypeScript configuration, which will be used when you bundle your app with Webpack instead of the default TypeScript configuration, and a few other files that we're going to go through later. Also, it adds a few dependencies, so we have to install them with npm install.
All right. So I guess around this.
Yep. And also it adds a few npm scripts so that helps you bundle your app.
Okay.
And real quick, I see the tsconfig AOT JSON. That's a new tsconfig file that it added, and the IDEs ignore that. That one's only used by the Webpack build. Is that correct?
Yep, that's right. And so we can also just open it and explain how is it different from the tsconfig JSON.
Okay. So what do you want me to open?
tsconfig.aot.json.
This one here.
Yeah. It's actually an extension of your standard tsconfig, and we're adding a few paths for just finding the TNS core modules. Why is that? Okay, can you open also the tsconfig JSON?
Yeah, sure.
Yeah, so the way that we are trying to resolve TNS core modules here is using that paths option. You can see it here. Yeah.
Oh yeah, over here, yeah.
This one. So the thing is that the ahead of time compiler of Angular have some problems with this type of resolving, because what it says here is if you try to find some module, first you try to find it in node modules / TNS core modules, and then if it's not there, try to find it in node modules, which basically makes the compilation process a bit slower, because it goes through everything in your node modules for every required statement you have in your app. And yeah, there are some problems with the Angular compiler that just throws errors like JavaScript heap out of memory. But yeah, that's just a side note. In the tsconfig AOT.json, you can go back on that one.
Yep.
We're just using more verbal spots for trying to find out each module.
All right, so basically we specify exactly where to look for, like console or FPS meter or any other components. I see.
And of course, also we have some options for the Angular compiler. They're 136, yeah. They're just specific Angular compiler options that can be found in the Angular documentation.
Okay, cool. Maybe, yeah, we could probably pass in a link for that as well. Might be a good read.
Yeah, sure. So now let's go back to Webpack. You have Webpack configuration that's generated, but actually you can just look at it later. And now let's go to the real stuff. We can just run Webpack and bundle our app and see what's the difference.
Right, so what do? TNS run Webpack?
No, not really. Not for now. Not to spoil anything, but maybe later, in a few months, you may be able to do that. For now, you have to use the npm scripts that are added by the NativeScript dev Webpack plugin. Yeah.
Oh, this one's okay. So what? npm run Android bundle.
Yeah, and you can use the start Android bundle just to start the app.
And can I still use timeline view like before?
Yeah, sure. Timeline view, but you should start the Android. Because build Android bundle just bundles your application.
Oh,
and
I see.
We also start it, yeah. And we need to start it so it can print all those things on the console, and the timeline view can fetch them and generate a report.
Cool. Is that all I need now, or?
Well,
yeah.
You can also add another option that's --uglify, just to make it quicker. Yep. That enables the Uglify plugin for Webpack. Yep, that's right.
So that's all I need, right?
Yeah, go on. That's going to take so we can talk.
Is there anything off the bat with Uglify, Stanimira, that you know would cause a problem with some projects?
Well, there are a couple of things. For example, right now, Uglify.js doesn't support ES6 code, so all of your app code and your plugins code, of course, should be ES5 transpiled. But that's going to change in the near future. Actually, right now, you can use 1.0 beta version of the Uglify.js plugin that supports ES6. So yeah, if you have some troubles with Webpacking your app, it's easier to switch off and on Uglify and see where's the problem, because it may be some Webpack specific problem. Any of the other plugins may cause it, and it may be just a Uglify problem. So what that option does, it's not magical in any way. While that bundling is running, we can finally open our Webpack configuration. That's
okay.
That's file at your app root level.
So what's the file I'm looking for?
Webpack.config.
Webpack. .config is it? Web. It doesn't see it here.
Just
there it is. Okay.
that's it.
I was just trying to be lazy.
So I won't go through everything it does, but we can look at 120. That's entry.
Mm-hmm.
So here we see all the, okay, not all, but some of the assets that we will produce while bundling our application. First one is bundle. That's going to produce the bundle.js asset, and that's our application code. And also everything that we have required in our app folder. So, for example, in our app folder, if in our, let's say, app components, we require some plugin, that's going to go into our bundle.js file. So yeah, that's your application code and everything you have required in your application.
Now, where does it get?
Yeah,
where does it get the entry model from?
That's a good question. By default, it's the main AOT.ts file, but you can specify that in your app/package.json. So
if we look inside the root package JSON, we should see that.
No, not the root one, but the one inside the app folder.
I'm inside app folder, and would you say, oh, package.json, this one?
So here we have main.js, but because we're using ahead of time compilation, okay, let's start from there. We have two files here, or we should have, if you're using the default NativeScript template, main.ts and main.aotts file. If it's here.
Yeah, I can't see the other main file. Maybe my VS Code is just hiding it.
Yeah, that's possible.
I think the latest version, when you install Webpack, I think it used to add the AOT file. I think I found that recently. At one point, it was adding the AOT file, and I'm not sure that the latest version, when you install it, adds that AOT.
No, it doesn't add. We're depending that you're using the default NativeScript template, and you should have it. So maybe you don't have it right now.
Mm-hmm.
You should.
Should I create it, or
yeah,
are we okay?
We can create it. That's right.
So AOT.ts.
Yep. So just a little bit about what's happening in main.ts. We're using the dynamic platform. Platform NativeScript dynamic to bootstrap our module. But for ahead of time compilation, after our modules are already compiled, we're use the static platform because it's gonna work with the already compiled modules. And so we're gonna import just platform NativeScript.
So what import would you say? I didn't hear you well.
I'm just gonna send it. It's platform NativeScript. Yeah, but just a second. Looks like that. It's just gonna be easier.
Oh, right.
Yep. Or basically, you can just copy everything from main.ts, and then we can do changes.
Oh, like copy from here.
Yeah.
All right, let's make the changes here. So
yeah, we just cut the dynamic part, and we import that from platform-static. And now is the cool part, because we're gonna try to bootstrap an app module ng factory, but that file doesn't exist right now. It's going to be generated by Webpack. We're going to import something from Fortwine, like wine4. App module.ng factory.
.ng.
Well, the file that we're importing from.
App module.ng factory.
No, at the end, like app.module.ng factory.
All right.
Yeah.
It's actually good we're seeing this added manually to understand more what this is.
Well, yeah. So we are gonna import app module, but it's not gonna be called that way. It's app module ng factory. I'm gonna just send it because like basic it's weird. Yeah, that's one.
Yeah.
So and because we're not bootstrapping a module, but we're bootstrapping a module factory, we're just gonna add the factory words here. Yeah. Well, that's it. That's basically it.
That wasn't that hard.
Yep. And as I mentioned, the TypeScript compiler will just complain about that import because app module.ng factory doesn't exist right now, but it's going to be generated by Webpack during build time, and it's going to be in memory. You're never going to see that file in your app folder.
Yeah, that makes sense.
To help circumvent the TypeScript error, the tsconfig ignores those AOT files. You might open that real quick, Sebastian.
Which one?
That's
the
right.
tsconfig file.
Yeah. The JSON one or just
the other one?
Yeah.
You'll see it's ignoring the AOT suffix files there.
Oh, I see.
We added that so the compilation when using NativeScript in debug mode and the TypeScript compiler, of course, shouldn't complain about these things. So yeah, probably your the building of your app failed because you didn't have a main AOT file. So we can run it again. The command we ran a few minutes ago.
Okay, let's see. Yeah, there's like a load of messy
errors
on my screen, so I can just rerun that.
And because we use Uglify, we see that funny error right here in your device. No ng model metadata found for E. Cool. So E was basically app module, and it got renamed because Uglify just mangles the names of your classes and your variables and makes them smaller.
Yeah, so definitely Uglify is not for debugging.
Yep. That's one good reason why we don't provide it by default, but with an option.
On the plus side, it took only half a second to fail.
Yeah, that's pretty fast, right?
Hey, that's a performance improvement.
So, okay, do you want to go back to the Webpack configuration?
Sure. Webpack config, yeah.
Yeah. So, yeah, this is how we get our entry module. It's specified in your app package.json, and if you're building an Angular application, we try to find if you have specified main.js file, we try to find main AOT.js file, right?
I see.
Yep, so that's why it didn't fail at build time, but at runtime. It's tried to bundle your app with main.js, and it just failed because we're trying to use the ahead of time compiler, and we don't have ng factory compiled module right there. We're bootstrapping the just-in-time module.
It's worth mentioning real quick that you could have A/B test versions of your app, and you could have a separate bootstrap file which you could indicate in the package JSON, and you could bundle out different A/B testing versions of your app that you might want to run through test flight or something like that.
That's pretty cool, yeah.
That's an interesting point. Right, so the app will run again.
Yep.
And it looks like it took, what, 2.5 seconds?
Yeah.
And here, well, here it says 3.2, which is already an improvement from 3.8.
Yeah. So basically, if you open the report again, yeah, just cancel that output, and the times HTML is regenerated. Yeah. We see that the first chunk, the onCreate chunk, got a bit smaller because we're doing a single require. If you see the require callback of a vendor.
Where is that? Oh, yeah.
Yeah. So once that vendor.js, maybe here is the appropriate time to open another file that was brought to you by the Webpack plugin. That's the vendor.ts, which is located in the app folder.
So vendor.ts, that's the one?
Yeah. So here we require a few npm packages, as you can see, Angular and NativeScript Angular. And because we require NativeScript Angular, and it's internally requires our TNS core modules, we can say that 3 of the biggest plugins that we have in our application are required here. And in our Webpack configuration, we have specified that all the modules that are required here will go to a separate asset that's going to be called vendor.js. So maybe we can, how can I show you how this looks like? Of course, we can open all these files in our platforms folder, but that's going to take some time, and we like to see things beautiful. So we also have included a Webpack plugin that's called Bundle Analyzer, and that plugin generates a report every time you bundle your app with Webpack. So that report is located, of course, in your report directory. There are 2 files. We're going to open the HTML one. It's not really beautiful, but of course it's HTML. We can open it.
Okay.
So,
whoa, what's that?
That's your app. Cool, right? So vendor.js, the one we were talking about, is it contains all these plugins: the TNS core modules, Angular, and NativeScript Angular. And you can see RxJS at the bottom right, probably because we use it somewhere in NativeScript Angular, or of course Angular uses it a lot. So RxJS is required by Angular, so it also goes into that asset. So yeah, vendor.js, it's pretty big, as you can see, and it's required at startup of your application. We also have a few more bundles, bundle.js that I mentioned, the blue one on the right side of the screen. Yeah. That's basically your application, your root module, app module, or you can zoom it actually. It's really cool. We have app module ng factory.
What's going on? Right, sorry.
We have that app module ng factory and everything that's required inside it. And also we have 2 other chunks that's with the funny names 1.js. You can go, yeah. So that's 0.js. Yeah, so that's 0.js, and there's one above it that's called 1.js. If you remember at the beginning, we separated 2 ng modules to be lazy loaded. So that's where they went. Webpack generated two separate assets for each of them, and they're not required at startup. That's a cool part. When you navigate to a page that uses one of these modules, they will be fetched from the file system and executed. So yeah, they are not executed at startup time. And also, there's a funny thing you can see here. We have that render.js file that's repeated 3 times. I saw it also in the bundle.js. So what's render.js? You can see it comes from NativeScript Angular, because right above it, there's NativeScript Angular.
Oh, yeah.
And how can we find where is it required? As I said, there are 2 files in your reports folder.
Okay.
This is the report HTML, and there is also a stats.json. So we can use a really cool tool that's provided to us by the Webpack team. I can send you a URL.
Okay. Let's see.
So it's basically webpack.github.io/analyze.
Let me open that.
So yeah, we should upload that file here. We can also drag and drop it just if it's easier.
Too many projects.
You have a lot of NativeScript stuff.
It takes time to build all this stuff.
So now the important things are our modules. We can go there. This is gonna be a bit shocking at first, but yeah, 309 modules. And this is how they're connected. This is the dependency graph. It's not a tree. And yeah, it's pretty beautiful. If you select something, you will see what is it. So yeah, it's gonna be pretty hard to find it that way, but yeah, we can just remove it from the URL. And now you can try to regenerate it.
Messed up.
Yeah.
Sorry.
It's okay.
All right.
So we can search here for the render.js file that we saw is included. Yep. So if we click on the 76, that's its number, it's gonna open a report for it. And the reasons tab you can see is why it's actually got in our bundle. And these modules are all the modules that required that bundle. So the first one that required is a file called nativescript.module.js. Let's go and see who required that module.
Okay.
Yeah, again, tapping on that. So it got required in our app module ng factory. That's actually the already compiled app module. So we can basically open the app module in VS Code and see where that happens. Our imports, and yeah, the second one is NativeScript module. We imported it here, and obviously nowhere in our vendor TS. If you can open the vendor TS, yeah, we can copy that.
Where is here?
The vendor TS, oh yeah. None of these modules required NativeScript module, so it never got into the vendor chunk. So we can do that manually. It just added require of NativeScript Angular. Yeah, we don't have to import it. We can just require it in old-fashioned ES5 way.
Like that?
Yeah, like that. And yeah, basically that's it. That will cause the render.js and actually everything from NativeScript.module, and it requires to go to that big chunk.
Now, is that kind of like the common chunks plugin with Webpack? Is that?
Yeah, that's right. If you open our Webpack configuration, we have the Commons Chunk plugin, which is by default provided from Webpack. Yeah, we can look it up.
There's one. This one.
Yeah. And here we just specify which asset to contain the common chunks. It basically says everything that's in that entry, vendor.js, should be only there. You know, if you have a require in your bundle.js chunk, it should be extracted to vendor.js, and bundle.js will just fetch it from vendor.js.
So that's going to reduce all the multiple render.js across the various different.
Yeah. It's gonna move them to our vendor.js chunk. And okay.
So I suppose we should rerun the build, right?
Yep.
So what happens, like this render.js is gonna go over to the brown side.
That's right. And you know, it may sound a bit weird at first. Why are we making that vendor.js chunk even bigger and bigger? I mean, right now it's like 2.7 megabytes, but of course that's before compression and solidification. Otherwise, it's around 1 megabyte, but never mind. So why are we making it bigger? And actually, we should always try to extract almost everything, all of our plugins in it. And so that's because we can use another cool feature that's called heap snapshots. And okay, I can tell you a bit about it.
Mm-hmm.
First, probably how we can enable it. You can actually, yeah, okay, we're gonna wait for this one. Yeah, I can go back to that process where here we are just running Webpack for building our JavaScript files. As you can see that asset processing and everything it prints, it's output from Webpack. And then we're running TNS run and building the NativeScript project, like the native Android project. We're just taking the JavaScript and building the native project using Gradle. So that's what the npm script does. Just cleans a bit the platforms folder, then runs Webpack, which takes care of the JavaScript files, and then it runs TNS run, which builds the native project.
That's pretty cool. So what improvement in performance should I expect from that? So we're on 3.2 seconds. What's your bet?
In my opinion, just a few milliseconds, because it's just tiny JavaScript file. But it sounds, you know, it can be a big plugin that you forget, for example, to separate in your vendor chunk to extract.
It's worth saying every single millisecond you can save while performance tuning is worth it.
Yep, sure.
So it actually looks like we're slower by 50 milliseconds.
Well, that's because different runs, you know, there are a lot of things happening in your device. So
actually, it's 2.5 now.
Yeah, there can be a few differences in terms of 200 or 300 milliseconds. It depends. The best way to profile is like to run the app 10 times and then take the average of that, because a lot of things happen on your device and you can never be sure what's the exact time.
That's because, Sebastian, you have 100 Snapchat and email notifications happening.
I try to do stop some of those, but yeah, I still think I have like 30 Chrome tabs open, so probably that's at fault.
Yeah, this one too.
Okay. So there's, like you mentioned before, we could do snapshots. as well. So how do we do that?
Yeah, we're just gonna provide a dash snapshot flag, just like we did with Uglify. Yep.
Like this?
Yeah, while this is happening, so what are these V8 snapshots? Yeah, I already said V8. So I'm gonna start a little further. So the NativeScript apps, while they run on Android, they actually run on top of V8. And as you probably know, V8 is a JavaScript engine that's developed by Google. And actually it's used in Google Chrome, in Opera, Electron, and of course in Node.js. So yeah, it's pretty well-known JavaScript engine. So that engine, of course, we use it for our Android applications. As a side note, for iOS, we use the Apple's JavaScript engine, which is called JavaScript Core. So back on V8, V8 provides that awesome feature, which is initializing a JavaScript context from a pre-generated snapshot, heap snapshot. You know, you just take the heap and make a snapshot of it, and then V8 can just initialize a new JavaScript context. Okay, in simple words, we can take that vendor.js bundle, and instead of just fetching it and evaluating it, doing everything that we're doing at startup time, and of course requiring the file from the file system, we can run our Webpack snapshot plugin, and we can execute it once during build time instead of startup time. And while we are executing it, I'll mention after that what tools we're using. So we can execute it, then just serialize the heap at the moment. We can take a snapshot of the heap, and we can serialize that to a binary file. So,
okay. So basically, it's what, like, we start the application, then V8 will do all the processing, and we kind of like save the game at that moment. And then next time we start the application, we start from the save. Is that what you're saying?
Kind of. We're actually not building a real application while running the snapshot tool. We're using a tool that's called MK Snapshot, which just executes the JavaScript code, the vendor.js in that case. So it executes the JavaScript code and serializes that the heap at the moment to a binary file. Then we include that binary in our app, in our APK bundle. That's our actually Android bundle, but never mind. So we take that binary file, and the Android runtime just loads it at startup instead of executing the JavaScript code.
Cool. So the build's finished, and it ran the application, and it took 2 seconds to start, I think, by the look of it, well, or 2.5. So I think from what I heard is when you, rerun the application, second test, we went down to even 2 seconds.
Yeah, that's good.
So that's a pretty good improvement from starting at what, like 4 seconds before loading the data, down to 2.
Yep. We can actually open the times HTML and just compare it with the previous version, just to realize what it does. You know, the onCreate chunk block, or whatever you call it, the one on the left, NativeScript application.onCreate. Yeah, it just got.
This one, yep.
Yep. No, the one on the left, the first one. Yeah, it's just 550 milliseconds instead of 1.5 seconds or something like that, whatever. That's because the thing that's gone, it's the require of the vendor.js asset.
I see. That's pretty cool. So obviously we don't have snapshot for Android, but then the startup time on iOS is better anyway, right?
Yeah, that's because that feature is provided by V8, and we're just using another JavaScript engine for iOS. And another important thing to mention is that the tools we're internally using to generate the snapshots, the MK snapshot tools, they're available only for Linux and Mac OS. So if you're using Windows for development, at the moment you cannot generate heap snapshots. So of course you can provide the -- snapshot flag, but it's not going to do anything. So yeah, that's something we'll be working on, enabling snapshot for every platform, more like every operating system, because it's not really possible to do it with JavaScript core for iOS. And yeah, that's it. That's our kind of final optimization.
Wow, that's pretty cool. So, okay, I'm gonna stop sharing the screen, or should I just find for the final look? We basically went from, well, excluding the data load, but that was like 5 seconds when we enabled lazy loading. Well, no, without lazy loading, 5 seconds. With lazy loading, we're at about 3.8, 3.9. Then we enabled Webpack, so went down to 3.2. And then with snapshot, we kind of went to 2 seconds, 2.5. Oh yeah, and there was the step as well where we included the vendor JS. So I guess the conclusion would be like, yeah, we should definitely do lazy loading. We should definitely try to use use Webpack, and then possibly if we up for a challenge, to look through the crazy graphs to kind of put some of the heavier component into the vendor TS file.
Sure.
Then,
By default, we're snapshotting the vendor JS file because, as you see, is the biggest one. And one constraint of the snapshot feature is that it can also only make a snapshot of a single file. So another thing you can do is, try to put all of your applications into a single file and then just snapshot. But, that's further optimizations. And
oh, cool.
yeah.
That's really nice. Okay, so I think we're running out of time slowly, but this was pretty insightful. So I guess like for each of those stages, we have some sort of articles. So you promised to share them with me. So I'll share them with like everyone on YouTube. Nathan, do you have any final questions? Any insights?
So final thoughts too, all really good stuff. Use the profiling tools to really get a metric. Oftentimes managers really like to see metrics, but they're great to go by, of course, to kind of determine where you're at currently and what you can get with some of these benefits. So definitely some of the profiling tools, the timeline view, some of those things that were mentioned there, to really get a view on some of that. Yeah, I think view simplification, we didn't get too much into looking at a specific view and reducing layout containers and that sort of thing. But just as a small point, you can also look at your views, and sometimes, especially those coming from the web, will have the tendency to layer layout containers, many in a row, that might cascade. And you want to try to avoid that as much as possible. The NativeScript views are a little more concise. And so you can often do more with your layouts with less. And so try to lean on either the grid layout or Flexbox layout to lay out everything instead of nesting a bunch of stacks and grids inside of each other, as you might divs on the web and that sort of thing. But we'll maybe save that for another episode.
Yeah, those are definitely pretty good hints, because I've been guilty of that, of having like a stack layout inside stack layout instead of stack layout, etc. And then, yeah, it sounds easy, but pretty much on the native layer, we have to create a component for each of those layouts. So that can add up.
But I think from this, what both of you went through, biggest thing right off the bat that's easy for most folks to do, engage with lazy loading. Fairly straightforward to do. Depending on how big your app is, it might take some refactoring to get things down into modules to where you can lazy load them. but it's one of the biggest things you can do for the startup time for sure. And then after that, these take a little more introspection with the analyzation tools to kind of figure out where else you can tune. But that was really well presented there.
Cool. So, and by the way, like I changed the code back to still the app when it was loading the data, because I'm curious what is the startup time now, even with loading the data. So maybe if it finishes in the next couple of minutes, I can share with everyone. So,
Stanimira, anything that the core team that you don't mind sharing that they may be working on that is either above and beyond in terms of performance or maybe even feature-wise? Anything that you're able to share that you're excited about?
Well, okay, I can share that we're working on that garbage collection chunk that takes a lot of time, and that's going to be a huge performance because, you know, that's taking like half a second when you start your app, and we're just trying to get rid of the synchronization between the two garbage collectors, the Java and the JavaScript one. So yeah, that's gonna be a huge improvement. And
So
we're also updating the version of our V8, the V8 that we're using in the Android runtime, which of course is gonna bring a lot of performance improvements. And yeah, basically that's it.
Those are also improvements on iOS as well. So the garbage collection improvements are for both platforms.
No, basically the garbage collector improvements we're doing in the Android runtime.
Okay.
It's Java code.
Gotcha. I was thinking that the recent PR that got merged in there that mentioned iOS profiling, and it looked like the memory heap was greatly reduced there. I don't know if that was a side effect of a different fix or not, but at any rate, it looked like the iOS runtime would be faster in the newest NativeScript runtimes.
Well, it will be because of the other improvement that you mentioned before. We identified some memory leaks and fixed them in our iOS runtime. So, yeah.
Last quick question, if I may. Absolute layout versus stack or a grid. Do you see performance burdens with using an absolute layout and fixed positioning layout containers inside an absolute layout?
Well, I'm not sure. I don't have a lot of.
No worries. I was hitting you off the spot. It's just something I've been curious about, but it's one of those that I'm suspect about because, of course, on even mobile, if you have a bunch of absolutely positioned elements on a page and then you take that same layout and view it across mobile web, it can degrade also on mobile web depending on how much you have kind of fixed position and absolute layout. There can be weird glitches that you might see in even browser rendering. So I'm suspect at the moment that the same type of issue can occur in NativeScript where you have absolute layout and you're trying to lay out your entire page with fixed position elements because you have a z-index and things can be rendered on top of each other in a view. So it'll be interesting down the line to look further into that.
Yeah, sure. Actually, never used absolute layout in NativeScript, but that's just a side note. But yeah, the layout system is pretty different from the DOM one, and I would go for grid layouts and stack layouts more.
Yeah, I think most people will find you can be just as versatile in that, but I was in the same boat that I think when I first encountered NativeScript, I was looking at layouts and like, oh, this is awesome. We have an absolute layout, and I could animate just elements wherever I want on the screen with a single absolute layout and then just fix position things all over and animate this thing there or move it there. And I think there's probably an initial temptation to probably do that, but you'll find you could probably do some similar things with a grid layout or a flexbox layout to achieve similar.
Yep.
Nice. So just FYI, I built the app and then rerun it with loading actually the data. So if I kill the application and then start it again, the full load time is just 2 seconds and 87 milliseconds. So it's like 2.1 second after all the optimizations and everything.
Nice.
So like even with the data load that by itself used to take like a second, 2 seconds, it's it's a lot faster. So even generating each of those tables, it became faster with all the Webpack and snapshots.
You can definitely feel that difference. A 2-second difference is very visible. You feel that.
Actually, we're talking about even at the very beginning, we took almost 7 seconds.
Oh, that's true.
Yeah, because that was the data load. So we shaved like 5 seconds, which is insane.
That's huge. That is huge.
Wow, I'm pretty happy with this. Maybe I should publish this up today.
Let's see it. Now I can learn about real football.
Yeah. Well, the problem is that at the moment, Man United is on the top of the league, so I don't want to see that. It's Liverpool second. So once they swap positions, and they will very soon, then I'll publish it with pride.
Excellent. Listen, thanks. Stanimira and Sebastian, really great info, and that was just very insightful.
Yeah, thanks for joining us, Stanimira. Thanks for all the insights. I thought I knew some of this stuff, but yeah, I still have a lot to learn. So we should definitely do it again. So thank you for your time.
Thanks.
We all do. Thanks for everybody.
All right. So yeah, I think I'll just grab some links from Stanimira later, and then I will share with you on the YouTube channel. So thanks for listening to us, and if you liked it, give us a thumbs up. If you didn't, don't bother. So yeah, see you at the next episode. Bye.
And NativeScript Developer Day in New York City. Anybody coming?
Yeah. And you guys should have. Yeah.
Yeah, everyone should have that shirt. No, look forward to seeing you two both there.
Yep. So if you come to NativeScript Developer Day, like Nathan was saying, you're gonna get one of those. And if you tell me that you've seen this specific podcast, I'll give you 2.
Oh, helpful.
All right.
That's awesome.
Bye.
Thanks.
Bye.
See you guys.